Good morning. Myself, Mujibur Rahman, Assistant Professor, Department of Automobile Engineering, Hindustan College of Engineering and Technology, Coimbatore. Today, we are going to see the various chemical structures of a petroleum product in the subject called Automotive Fuels and Lubricants. Chemical structure of petroleum. We know that we are getting the petroleum products from crude oil. The crude oil are nothing but the decomposition of organic matter in high pressure and temperature. Since it is made up of organic components, it will have hydrocarbons. The petroleums as obtained from the oil well is predominantly a mixture of many hydrocarbons with the different molecular structures. It also contains small amount of sulfur, oxygen, nitrogen and impurities such as water and sand. The carbon and hydrogen atoms may be linked in different ways in hydrocarbon molecules, and this linking influences the chemical and physical properties of different hydrocarbon groups. Most petroleum fuels tends to exhibit the chemical characteristics of the type of hydrocarbons which forms a major component of fuel. The table which shown here gives you the full details of the general formula, molecular structure and the saturation or unsaturation of different kind of hydrocarbon families. Let us see in detail. In general, there are four families in hydrocarbons of petroleum products, namely paraffin, olefin, naphthalene, and aromatic. Let us see the difference between all those four type of hydrocarbons. First case, paraffin. Paraffin has the general formula of CnH2n plus 2. Here, C is nothing but carbon atom and H is nothing but hydrogen atom. This paraffin has a chain type of molecular structure and it is a saturated one. Saturated means it contains the greatest possible number of hydrogen atoms without carbon carbon double bond or triple bonds, which means it is easily soluble, it is easily breakable. Here, in this type of hydrocarbons, the chain or link can be easily broken and a desired chain of structure can be obtained. It is very easy and it also very stable. Next, olefins. Olefins has the general formula of CnH2n. This also has a chained type of molecular structure, but it is unsaturated. Unsaturated means having of high carbon carbon double bond or triple bond and therefore not containing the greatest possible number of hydrogen atoms, which means you cannot or it is highly tedious to break this chain. You need to get more energy to break this bonding because in olefins the carbon and carbon atoms are molecularly connected by means of double bond or triple bond and it is also a unstable one. Next, third one, naphthalene. Naphthalene has also the general formula same as olefin, that is CnH2n, but the major difference is it will have a ring structure when you compare with olefin. That is, olefin will have the molecular structure of straight chain, but naphthalene will have a ring type of structure. Another difference is it is a saturated one where you will be having a higher possible of hydrogen hydrogen bonding rather than carbon carbon bonding. It is also a stable one. Finally, the last type of hydrocarbon family, aromatic. This aromatic type of hydrocarbon family will be having a general formula of CN H2N minus 6, and it will have the same as naphthalene ring type of molecular structure, but it is highly unsaturated and most unstable. This type of aromatic components can be used as a polar solvents. The examples such as benzene. The benzene molecule will be having a chemical or molecular formula as C6H6, and it will be having a ring structure. The basic difference between naphthalene and aromatic is the general formula and the saturation level, but both will have the same ring structure like this. Here you can see the examples of straight chained molecular structure, methane, which has one carbon atom and four hydrogen atoms, and ethane will be having two carbon and six hydrogen. Likewise, propane, three carbon and eight hydrogen atoms. So, this type of molecule structure comes under paraffin, where you can see it is a straight chained molecules. Next, this is the chemical structure of the benzene. It is in the structure of ring, where you can see it is a closed loop, and it also has double bonds. You can see we are having six number of carbon atoms, where those three sets of carbon atoms are being linked with double bonds. These double bonds indicates that it is highly or tedious to break these carbon atoms. Either you have to give external force such as chemical process like thermal cracking or catalytic cracking to convert this ring type of structure into a straight structure. So these are the different kind of hydrocarbon families which we can see in a petroleum products. Thank you.